back at number 1. When you are finding the side lengths in a right triangle, you're using the Pythagorean theorem, which is a squared plus b squared equals c squared. Now, c squared is our hypotenuse, so that's what is already given. We're looking for a or b squared. So I'm just going to make x a, so x squared. I'm going to say this is b, and we know that the hypotenuse has to be c. Okay, so b is 13 squared, and c squared 15 squared. Okay, if you were looking for the hypotenuse, then you would have had this open, and I'll draw one out because I didn't put one on here. All right, so x squared, we can't do anything with that. 13 squared is 169. 15 squared is 225. Okay, so we are solving an equation. We subtract 169. 225 minus 169 is 56. So x squared equals 56. Okay? In order to get rid of a square, we got to take the square root on both sides. So x is root 56. Now I need to see if 56 will simplify. And it will. So I know that that's 2 times 28, which is 2 times 14, which is 2 times 7. Now I'm down to prime numbers. So, find my pairs. I got a pair of 2s, 2 and a 7 alone, so they stay home. So then I can multiply 2 times 7, which gives me 2 root 14. Now, I just want to show you how to set up one. Just so you gave us 3 and 4, and we're looking for the hypotenuse. Well, then you're going to set it up 3 squared plus 4 squared equals x squared. Multiply that out, that's 9 plus 16, that's 25, and then square root it. And so x is 5, okay? That's how you would do it if it was normal and you're looking for hypotenuse. Now, number 2 is asking us to find each side length and then round to the nearest tenth. Okay, so the one that gives us 2 is the one we can do first because we can find the third one. So, we can find this length by doing what we just did. This is going to be our A, our B, our C. C has to be the hypotenuse. A and B doesn't matter. So A squared is 8 squared plus B squared, or X, whatever you want to use, is C squared, which is 13. So that's 64 plus B squared equals 169. So now I can get B squared by itself by subtracting 64. So I know that b squared is 105. Okay? To get the b by itself, you take the square root on both sides. So b is root 105. Now, okay, I know that this won't simplify, but I'm going to show you what you do if you don't know. Try it out. That's 5 times 21. That's 3 times 7. If you have no pairs, we got a 5, a 3, and a 7. Those would all go back under, and those would multiply to give you 105. So it wouldn't change anything, and there's no point in writing root 105 again. You just go back to that original answer. Now, the converse of the Pythagorean theorem tells us a couple of things. It can tell us if a triangle is a right triangle, and it can tell us what type of triangle it is. Is it a right triangle? Is it an obtuse triangle? Is it an acute triangle? And technically it could say it's not a triangle. Okay? So we're trying to decide, are these acute, obtuse, or right? So biggest thing you got to know is which one's C, and that's your hypotenuse. Okay? If you get that C squared equals A squared plus B squared, then it's a right triangle. If you get that C squared is greater than A squared plus B squared, it's an obtuse triangle. And if you get that C squared is less than A squared plus B squared, it is an acute triangle. Okay? So let's look. And we know that this is C squared. So that's root 14 squared. I'm going to put that in parentheses. Equals, we're going to put equals, and then we'll decide is it equals or is it greater than or less than. I'm going to say this is A and this is B. So root 5 squared plus 2 squared. Okay, now, anytime I square a square root, I'm going to get what's under the square root. So this is 14. This is 5. 2 squared is 4. So I got 14 equals, when you add those, 9. Okay, we know that they're not equals. 14 is greater than 9. So that means that our triangle here, if it's greater than, is obtuse. Okay, so super simple. So let's do number 4. This is our C, because it's our hypotenuse. So we got root 145 squared. I'm going to say equals. I'll make this A and B. So 9 squared plus 12 squared. When I square a square root, I get what's under the square root. So it's 145. 9 squared is 81, and 12 squared is 144. So I'm going to add those up. 81 plus 144 is 225. Okay, so I get 145 equals 225. Now, I know those aren't equal. 145 is less than 225. If it's less than, it's an acute triangle. Okay? Super simple. Alright, let's finish up. Hey guys, today you have a short assessment on radicals and the Pythagorean theorem and the converse of the Pythagorean theorem. So I wanted to do a little review to go back over those things. So I want to look at the radicals first because that's going to be first on your assessment, and then I'll go back and look at Pythagorean theorem and the converse. So we're going to start on number 8 and through 8 through 15, and then we'll go back to the first page and start at number 1. So let's look. All right, when you are just simplifying, there's no operation, no addition like here, or subtraction, or multiplication, or fraction bar, which is division. Then you are going to just simplify, which means you do a factor tree or however you've chosen to simplify. So I know that 2, actually let's do 3. I know that 3 goes into 600. We know that 6 and 10, but those will have to break down. I know that 3 is a prime number, it's not going to have to break down. So I'm going to use 3. 3 times 200 is 600. Okay, I know that 2 goes into 200 100 times. Okay, now, when I know that 100 is going to separate into pairs, I'm going to go ahead and use the pairs, okay, because it's going to make it simpler. However, you could do 2 times 50, and then 2 times 25, and then 5 times 5, and keep going. Or you could split this into the pair that already exists, which in my opinion, is the easiest thing. But you could keep going. Okay, so now once we've run into a pair, we're going to use that pair, and it can come out. Remember, if it has a friend, it can go out. 2 and 3 are alone, so they got to stay home, and they're going to be multiplied together. Okay, so 10 root 6, because we multiplied 2 times 3, is your final answer. Okay, so let's look at another one. Root 180. I know that 2 goes into 180 90 times. Then I know that 3 goes into 90 30 times. Okay, let's do it up here. 2 and 90, 3 and 30. Then I know that 3 goes into 30 10 times, and 2 goes into 35 times. Those are all prime numbers. Okay, so once I'm there, I can find my pairs. So I know that I have a pair of 3s. So 3 is going to come out. I also have a pair of 2s. So a 2 is going to come out, and we're going to multiply that by the 3. If there were other pairs, then they would come out and multiply also. And 5 is alone, so it's got to stay home. It has no other 5. So now, once you're there, you can multiply 3 times 2, which is 6, and then root 5 stays the same. Okay? That is simplified. Now, let's look at addition and subtraction, which is 10 and 11. In order to add or subtract, you have to have the same number under the radical. Okay, none of those are the same number. So it's like fractions. You have to have the same denominator to add fractions. You have to have the same radical to add or subtract radicals. So, in order to do that, I know that 5 won't simplify because that's just 5 times 1. There's no other factors for that. So, all that we have to do is 20. Okay, so I know that 20 is 5 times 4. And I know that 4 is 2 times 2, which is going to give me a pair of 2s. So a 2 comes out, and there was already a negative 2 there. So it's negative 2 times the 2 that gets to leave. 5 is alone, so it has to stay home. We didn't change this one, so we're just going to bring it down, minus 3 root 5. Every single time you do that in addition and subtraction, you should end up with the same number under the radical. Okay? Once you do that, we know that negative 2 times 2 is negative 4. And then once everything is simplified, now you can add or subtract these. So we have the same radical, so we can say negative 4 minus 3, which is negative 7. Keep your radical root 5. It doesn't change. Okay? So number 11 works the same way. However, 24 and 54 will both break down. So let's do that. I know that 24, I'm going to say 3 times 8. I know that 8 is 2 times 4, which is 2 times 2. Okay? So I have that negative 2 on the outside already, and then I have a pair of 2's. So I'm going to multiply by that 2. 3 and the other 2 are alone, so they got to stay home and be multiplied. So that gives me negative 4 root 6. I multiplied and multiplied. Okay, now I'm going to break down 54. I know that 54 is, let's say 9 times 6. And then I know that this breaks down into 3 times 3 and 3 times 2. Okay, so I have a pair of 3's. So look, plus, and let's put it here. We got the 3 on the outside already, and then we got a pair of 3's that's got to come out. Then we had a 3 and a 2 that were alone, so they have to stay home. Okay, so when I multiply, 3 times 3 is 9, 3 times 2 is root 6. And again, once you simplify everything, you should have the same radicals. So now, negative 4 plus 9 is positive 5, and your radical stays the same, root 6. Okay, that's addition and subtraction. So let's look at multiplication. In my opinion, multiplication is the easiest. So let's look at that. You're doing outside times outside, which is just 4. Inside times inside. 15 times 20 is root 300. Okay, now, all you got to do is simplify that here. We've already no, we haven't. We haven't simplified 300. So this is 3 times 100, which is 10 times 10. Anytime you see 100, 25, 36, 49, 9, 4, they're going to break down into pairs. Those perfect squares break down into pairs. Okay? So I have a 10. That's a pair. It can come out, and I had a 4 on the outside. So it's 4 times 10. 3 is alone, so it's got to stay home. Now you just multiply. 4 times 10 is 40 root 3. Okay? Number 13 works the same way. You are not trying to find a common radical here. Okay? You are multiplying outside times outside, which is negative 12, and inside times inside, which is root 48. And once you get there, then you simplify. So 48, I know, is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Okay, so I'm going to circle my pairs. I got a pair of 2's here and a pair of 2's here. We already had negative 12 on the outside, so that's negative 12 times one of your 2's times another 2, and then 3 is alone, so it's got to stay home. Okay? So we're multiplying. Negative 12 times 2 is negative 24 times 2 is negative 48 root 3. Okay. Division. And I'm going to erase some of this so you can see what's going on. Alright, division. When you have a radical on bottom, you got to rationalize. So we're going to rationalize by multiplying by root 12 over root 12. Okay, so outside times outside, 5 times nothing, which is technically a 1, is 5. 15 times 12 is 180, I believe. I'm going to check that. Okay, yes. Okay, on the bottom, we got the 2. And remember, root 12 times root 12 is just what's under the root, which is 12. So we're going to multiply by that 2. So we got 5 root 180 over 24. Now, if that radical will simplify, you need to simplify. So I know that 180 is 3 times 60, which I know is 3 times 20, which is 2 times 10, which is 2 times 5. And I'm going to circle my pairs. Now, I got this 5 on the outside already. Then I'm bringing out a 3, and I'm going to bring out a 2. So those all have to be multiplied. And then this 5 was alone, so it's got to stay home. And I don't know why I have an equal sign. So now, multiply. 5 times 3 is 15, times 2 is 30, and the root does not change. Okay, last one of the radicals. So we're going to multiply by root 20 to get it off the bottom. That gives us root 100 over, remember, root 20 times root 20 is just 20. Now, root 100, you could work it out and simplify it, but I know that it's a perfect square, and the square root of 100 is 10. So I have 10 over 20, which will simplify by 10. 10 goes into 10 once. 10 goes into 20 2 times. So my answer is 1/2. Okay? All right, now, let's look with 5, 6, and 7. All right, so we're doing the same thing on number 5. This is our C. I'm going to make this A and B. So, root 11 squared equals, because it's our C, root 5 squared plus root 6 squared. Now, this one's easy because they're all under roots. So when you square roots, you get what's under the roots. So that's 11, 5 plus 6. 11 does equal 11, so that is going to be a right triangle. Okay, now, when we're trying to determine if something is a right triangle, we do the same thing that we just did, and if we get 2 equal sides, then it is a right triangle. And if we don't, then it's not. You just got to make sure that you're using the right thing for C. So we're going to say A and B. So 2 root 7 squared equals root 14 squared plus root 14 squared. Okay, 2 root 7 squared, you square the 2 and you square the root 7, which is going to be 7. Then, when you square these, you get 14. 4 times 7 is 28. 14 plus 14 is 28. So that is a right triangle. Okay? If they don't equal, then it's not. You just say no. So this is our C because it's our hypotenuse. And then I'm going to make, it doesn't matter which one you make, A or B. So root 226 squared, not plus, equals 13 squared plus root 53 squared. Alright. Root 226 squared, when we square root, you get what's under the square root, so 226. 13 squared is 169, and again, when you square a square root, you get what's under the square root, so 53. Okay, I'm adding 169 plus 53, and I get 222. 222 does not equal 226, so that one is not a right triangle. Okay? If you have any questions, let me know. This kind of ends up being a long video, but it's a good review, and then you can use it to help you with your assessment. I think there are 15 questions on the assessment, so make sure you get that done. Hope you have a great day, and hope you have a great weekend. See you later.